All right, guys, so tangent and cotangent. We're going to look at a couple different things than we did with all the sine and cosine stuff. All right, guys, so if I'm over here at 0, right, 0 degrees, 0 radians, the ordered pair is 1, 0, correct? Hopefully we know that by now, right? Okay, tangent, remember, of any angle is y over x. So what is the tangent of 0 going to be? It's 0 over 1, right? Is that 0 or is that undefined? 0. Okay. That is the first point on my graph. So, 0, 0. There we go. I know, it's all like, it's like the first page backwards. Remember, it's stapled in the wrong order. I don't know. Everybody on the right page now? Okay. With tangent, I am not going to go all the way up here to pi over 2. I'm going to stop at pi over 4. Okay? Why do you think I'm picking that point? What's the tangent there? 1. Is that pretty easy to graph? Okay, good. So when I'm looking at pi over 4, I get 1. So that means on my graph, my next tick mark is going to be pi over 4. And yes, I'm labeling my y-axis. See, I'm going every 2 tick marks is 1. I know. All right, so pi over 4 gives me 1. Let's go to pi over 2 next, up here. That ordered pair is 0, 1. So what is the tangent of pi over 2? 1 over 0, right? Undefined. What shows up on a graph when it's undefined? Okay. So, this is pi over 2. And that's where I have an asymptote. Why? Undefined. Pi over 2. With an asymptote drawn through it. Okay. I'm not going to go all the way to pi. Where am I going to stop? 3 pi over 4. Good. That's negative root 2 over 2, root 2 over 2. So what's the tangent there? Negative 1. Good. So on my graph, that next tick mark is 3 pi over 4. And my point is at negative 1. Okay, now I can get all the way to pi. Negative 1, 0 is the point. What is the tangent of pi? 0. Okay. Back there. This is pi. Okay, not real pretty yet, but we're getting there. I'm going to label the left side. Negative pi over 4, negative pi over 2, negative 3 pi over 4, and negative pi. Do you know what's happening at any of those spots on the left side of the graph? Like, do you know which one's going to be the asymptote? The negative pi over 2. Good. Which one do you think is going to be 0? Negative pi. Okay. So we just have to figure out these pi over 4s. So negative pi over 4, guys, what quadrant is that in? Remember, that means go backwards. So negative pi over 4, where is it? 4th quadrant, right? So is that positive 1 or negative 1? Negative. Okay, so that's down here. Okay, remember negative, you go backwards. So negative 3 pi over 4. What quadrant does that end up in? Not the second. Third. Yes, third quadrant. Tangent positive or negative in the third quadrant? Okay, so you see positive 1. All right, so there are the dots I need. It's not real pretty. Do you think I connect it like that? No? Probably not, right? We got some asymptotes going on there. So, that's the magic pen, okay? It's gonna look like this.
Whoa.
Ooh.
Tricky.
That's pretty. There we go. Now, why do you think I only went out to pi on the x-axis? Why didn't I go all the way to 2 pi? What do you think? It would have been repeated, right? Yeah, okay. That's because tangent and for cotangent, the period is only pi over b instead of 2 pi over b. They're different, okay? Just for tangent and cotangent. So those are what are considered your normal labels for the x-axis. That's your parent graph dots, parent graph labels, all that stuff. Okay. All right, domain and range of this. You guys should be better at the domain now. It's the same idea as secant and cosecant. So x such that x is an element of the reals, but x cannot equal, what do you think? What can it not equal? Pi over 2.
Pi over 2.
Plus or minus? If it was pi over 2 in between them, you'd have another asymptote at 0. How far is it from negative pi over 2 to positive pi over 2? Pi. So it's plus or minus pi k.
I thought it was just because they were like
It's just from one asymptote to the next. How far is it? Guys, what do you think the range is on this one? What do you think the range is going to be for every single tangent? Okay, yes. So that's nice and easy. Okay, cotangent. What is cotangent in terms of x's and y's? X over y. So what I want you guys to try to graph it. So think about, you're only going to need this part of the circle, okay? Think about what the cotangent at those points will be. Your x-axis labels are just the pi over 4, pi over 2, 3 pi over 4, and pi. Okay, I'll go back to this page if you want to reference it. And I'll give you a minute here to try. Yes. That looks great. I just said graph cotangent. So what would cotangent be right here? Okay, cotangent is x over y. Yeah, so that would be the You're just looking at it. Guys, did you get an asymptote on the y-axis?
Yes.
Yes. Where are the other asymptotes? Okay. Nice. The pi over 4s and 3 pi over 4s, those end up just being the same values as tangent, right? Because y over x, x over y, 1, 1, it's all the same. So this is still here. This is still here. This is still here. This is still here. What happens at both pi over 2 and negative pi over 2? It's 0, right? Okay. So those are your dots this time. So this graph is going like that. How do we do? Good? We're okay? Kind of okay? Anybody going, what in the world? Why is that so different than tangent? I don't understand. Please ask me if you're lost on any part of that. All I'm doing is thinking about the circle and doing x over y instead of y over x. Yes.
So like, if it's just like, if the period is like 1, it's going to be pi, not 2 pi.
Yes. Exactly. Yeah, if that b value is 1, the period's 5. Okay? All right, what's the domain of this one? X, such that x is an element of the reals, but x cannot equal 0 plus or minus k. We know the range is always going to be okay. Yeah? Not bad? We're okay? Some of your faces don't say that you're okay. You okay? Yes? Okay. Any questions? So again, just like we did with the sine, cosine, secant, cosecant, these are your parent graphs. So we're going to change things. We're going to change b values, all of that. But as far as like position of the dots and asymptotes, this is where they start. Okay? All right, so let's do one together. So turn the page somewhere here. I have the other page. There we go. All right, so let's look at number 5 together. All right, what is the only change that is, oh, are you guys finding 5? Sorry, just flip that page over. I know all the pages look the same. You can do it. We all on number 5, y equals tangent of x minus 5. You with us, John? John got lost in his pack. You're not alone.
Why have so many pages that look the same?
I know, they do look very, very similar. You gotta read the headings. Notes.
You know what? I thought for you.
All right, so what's the only thing that's happening? Shifting, which way? Right by pi. Okay. Is there a b value that's going to change any labels or anything like that?
No.
No, so let's go ahead and label them. Pi over 4, pi over 2, 3 pi over 4, and pi. Yes, you have to do the negatives. And do something on your y-axis. Okay. I am not going to sketch asymptotes yet. I'm just going to put the dots of the graph. So tangent is the one that goes through 0, 0. Then it's up to 1. And normally as an asymptote, -1, 0. Follow the pattern on the left side. I think it's helpful when there's a shift, don't sketch your asymptotes until the very end, because otherwise you have, like if your asymptote moves off of itself, you just have asymptotes everywhere. I think it's very complicated. Okay. So the shift this time is right by pi. But what is the period of this graph? Pi. So if I shift by the period, what happens? Yeah, it looks exactly the same. So go ahead and put in your asymptotes. Let's practice domain. Range we know, right? Negative infinity to infinity. Domain, we'll squeeze it in here. X, such that X is an element of the reals. X cannot equal pi over 2 plus or minus. Okay, good job. Remember how scary that was the first time we wrote that? It's not. Okay. All right, let's look at 6. What's happening in 6? What does the plus 1 do? Up 1, okay. Then we have this 1/2 in front of the x. What does that change? Yeah, the period. So remember, the period for tangent and cotangent is pi over b. So in this case, it's pi over 1/2. So what does that actually make it? 2 pi. Could you label the x-axis if you know the last one is 2 pi? I think you probably can. Okay, you have different labels now, but let's put those dots in the position that they're normally in. So the first tick mark for cotangent is usually at 1, then 0, then -1. Asymptotes on the end in the middle, 1, 0, -1. So make sure you have those dots. Okay with that? You see how we're not plugging values in, we're just still going, okay, here's where the dots are. And then I have to shift up 1. Okay? So you're going to take each dot and just move it up 1. Does that change your asymptotes at all?
No.
No, they go forever. Up and down, so they're still in the same spot even when you move them up 1. And then you just sketch the shape. Range we know. Find somewhere to write domain. I feel like I'm running out of spots. X such that X is an element of the reals. What can X not equal this time? 0 plus or minus 2 pi k. Okay, do you guys see when the period changes, that domain ends up changing? Okay. stop there for a second, make sure you guys are okay. Yes. Yeah, I know you definitely cannot read that. Let me try to read it. Okay. Questions so far? Okay, let's look at 9. I want to edit it just a little because the 1.5 is really annoying. Okay, so let's make this one say, let's just make it 2 tangent of 2 times x minus pi plus 1. There's a lot of stuff going on here. So we have a 2 in front. Now guys, technically it is not called the amplitude anymore because the amplitude is measuring height. And doesn't tangent go to infinity? So can I really measure how pi it goes? No, okay. But I can vertically stretch it. So it does the same thing, we just don't call it amplitude. Technically, sine and cosine are the only ones that actually have amplitude, okay? So we still stretch by 2. Then I have a 2 for a b value, so what's that going to change? Okay, the period is pi over 2. We'll put that last tick mark in there. Then it says minus pi, so where am I going? Right pi. Is that going to change anything? No, because isn't that just like shifting 2 periods worth of this graph? Right? Do we see how right pi is just all the way around? Okay, and then plus 1, up 1. So technically we are going right pi, but you won't see it, and we're going up 1. All right, do you know the other labels that we would have? What did you say? Pi over 8, good. Pi over 4, 3 pi over 8, good. All right, so let's think about parent graph dots for tangent. Can we stretch by 2 as we plot them? Okay, the ones that are at 0, are they going to change at all? No, 0 is still going to be there. Next tick mark is normally at 1. Where will that be? 2, okay. Asymptote, -1 will be at -2. 0 is at 0. All right, where do I have to actually move the dots now?
Up 1.
Up 1. Okay, everybody understands right pi is not going to change it?
Yes.
Okay, so just up 1. That goes all the way up to 3. So it's a slightly like taller, skinnier graph, and then shift it up. Okay. domain. What's it gonna be? What can X not equal? Pi over 4, good. Plus or minus? How far apart are they now? Yeah, pi over 2k. And our range. Okay. Anybody questions? How we doing? Okay. I like it that we have a whole nother day of just practicing all the graphing. I think that'll solidify some things for you.